All right, guys, before we get started today's lessons, are there any questions on any of the assignments thus far?
Oh, I have homework for you.
Okay. Thank you. 41, you got no solution.
Oh, wait, I didn't do that.
Lily?
Yeah, because that's wrong. It's too much.
To chapter 5, section 4. 41. Negative 18 does work.
Oh, it does?
Yeah. Because the one that you were doing was the cubed root of 2s plus 9 equals negative 3. So the first thing we did was cube both sides, which tells us that 2s plus 9, these cancel, is equal to negative 27. Minus 9 from both sides, telling us 2s is equal to negative 36. Divide by 2, s is equal to negative 18.
Yeah, I wasn't sure because all the notes that we did, all the other questions have.
Negative 18 plus 9. Yeah, and we can plug it back in and check it. Now, and that's really the key thing with any of them, is if you're not sure, check it. Plug it back in and check it. Because here, we took the cubed root of 2 times negative 18 plus 9. Well, this side is, if both sides are the same, it works. If they're not, then it doesn't work. And the one that we really can't have, guys, a negative in is if it's an even root. So second, 2, 4, 6. And what finishes up inside here is negative. So if we took, say, the square root of negative 18, it doesn't work. Cubed root of negative 18 does. Any even root, we can't take have a negative inside of it. Or, because we can have this, a cubed root can equal a negative number. An even root cannot equal a negative number. Any other questions on homework? All right, guys, so let's look at the notes for today. Now, what we're doing today is not going to be anything really overly different than what we did Thursday, except if you notice here, we have a variable outside the radical. We have some inside and we have some outside. Now, the steps are really not going to change. Our first main step is there one. You don't have to. Is there one radical? If yes, get it by itself. If no, then even it out. 2, put both sides to the nth power. If they're still radicals, repeat steps 1 and 2. And lastly, solve. And then for most part, everything we're going to do, step 3 is really never going to come into play for what we're going to do. We will see one in 3.4, or or 5.43, where we do have step 3 come into play. And we'll mainly just look at that. We won't do a whole lot with it. I do want you to see how it works, because it doesn't make things incredibly difficult. It's not going to be, this here is very similar to Thursday, and then what we do with 3 or 5.43 is worlds different. It's just repeating the same steps again that we do for the start. Now, if we look at this here, x is equal to the square root of x plus 6. We have one radical, yes? So we need to get it by itself. Well, it is by itself, yes? So now we can put both sides to the nth power, so we put it to the second. On the left-hand side, x squared is just x squared. On the right, the square root and square would cancel, giving us x plus 6. Yes. Since we have an x squared, a term, a variable with a power greater than 1, we need to get this equal to 0. Now, we could. Was that right? So x squared minus x is going to be x squared minus x. Since they're not like terms, we can't subtract them. It'd be nice if we could, make things a little bit easier. But since it's still not equal to 0, we have to. And this x squared minus x minus 6 is equal to 0. So now we have a quadratic, and we need to solve this quadratic. So we can solve it by factoring, graphing, quadratic formula. Any of these would work. If we factor it, first thing we look at is the signs. Since the third term is negative, our signs are opposite, plus and minus. Now we look at the factors of the first and third term. Only factors of x squared are indeed x and x. 6 is 1 and 6, or 2 and 3. Which one's? Yes. 2 is positive, 3 is negative. Since we do have two things multiplied together equals 0, one of them must be 0. To solve for one of the x's, we would subtract 2 from both sides. Telling us x is negative 2. Together we would add 3, telling us x is 3. Now, whenever we have a variable outside the radical with solving, we definitely need to check these. We definitely need to check these. So the first one we can check is negative 2. So we're saying negative 2 is equal to the square root of negative 2 plus 6. Well, on the left-hand side, we just have negative 2. So we have there. The other side, we could plug this into a calculator. Clear all that out. We can say second square root of negative 2 plus 6 is 2. Now, is negative 2 equal to 2? So we can say x is not equal to negative 2. Negative 2 is an extraneous solution. It's a solution that we do get from our steps in solving the problem, but does not work in the original problem. We can do the same thing with 3. Well, on the left-hand side, having just 3 by itself is indeed 3. On the other side, second square root of 3 plus 6 is 3. So the solution for this here is x is equal to 3. And the number that comes out of a radical has to be positive. The number that comes out of a square root has to be positive. And that's kind of why we're having an issue here. And while the main part of the issue comes in our steps with solving. Because this step here, where we square both sides, it's turning whatever it's equal to be positive, because the number times itself is always positive. And if that value of x ends up being negative or causing this side to be negative, there's no way to offset it. There's no way to change it. So it's always good to plug it back in. Questions on this so far? Now looking at this here, is the radical by itself? Yeah, so we can do what? Square both sides, which will tell us that we have x squared is equal to 20 minus x. Yes. Then we can add x to both sides, which will tell us that we have x squared plus x is equal to 20. X squared plus x minus 20 is equal to 0. X and x, plus and minus. So 1 and 20, 2 and 10.
2 and 10. 4 and 5. 4 and 5. 4 and 5. Yeah, that's 1. And then 5 would be 5 and 10.
Yes. So we're saying that x plus 5 is equal to 0, and x minus 4 is equal to 0 because of our zero product property, which states that any two things multiplied together to equal 0, one of them must be. So x is equal to negative 5. If we were to guess, which one do we think would not work? Negative 5. Because if we look back at the original problem, x is equal to the square root of 20 minus x. Well, with negative 5, we have negative 5 is equal to the square root of 20 minus negative 5. We'll still have negative 5 here. If we plug this into the calculator, the negative and negative would make a plus, which would be 25. And the square root of 25 is 5. And with 4, because 20 minus 4 is 16. Square root of 16 is indeed 4. So we're going over these here, yes. So 4 is indeed equal to 4. Questions on this here? We good with this here? Yes. So do we feel comfortable with these here? Yes. Yes. There should be some in the closet. So if we feel comfortable with these here, we'll move on to the next type. Yes. Because, I mean, these here aren't any harder than what we did last week. It's just we have a variable on the outside.
Which really doesn't make a difference.
It's just we end up getting an extraneous solution because of that. Because when we square it, it's really turning that to be positive. We have that offset where, as we've seen on the last two, when we plug it back in, we don't have that square anymore, which the negative solution doesn't work. Yeah. We're going to look at this one next. So, looking at this one here, solve 13 plus the square root of 5n is equal to 3. Well, step one, is there one radical? Yes. If yes, then get it by itself. So what can we do to get the radical by itself? If we subtract 13 from both sides, we get that the square root of 5n is equal to negative 10. So we got the radical by itself, so we can put both sides to the nth power. In this case, it'd be the second, which is telling us that 5n is equal to, because these do cancel, so 5n, negative 10 squared. So negative 10 times negative 10. It'd be positive 100. A negative times a negative is a positive. Divide both sides by 5. Right. So half of 100 is 50. How many times does 5 go into 10? 2, so it'd be, yeah, 20. Yeah, 100 divided by 5 is 20. 100 divided by 4 is 25. Let's go on and plug it back in and check, make sure everything works. Well, 5 times 20 is 100, yes? I don't think so, because you can check the fridge and see. Square root of 100 is 10. 13 plus 10 is, and this is supposed to equal what?
So, no. So, no solution?
Mm-hmm.
Okay. You know what?
I'm going to go backwards. I'm going to go back to a certain step in this problem here. And it's right here. So we got the radical by itself, yes? And we've said up to this point, because when we talk about this here, the square root of 5n equals negative 10. I'm going to write it in another way. Square root of x equals negative 10. And when we take the square root, we're trying to see what number times itself is x, yes? But whenever we talk about a square root, the number that comes out of the square root has to be positive. Now, I didn't show this in the other classes, but if we looked at just the square root function, square root of x, the only place that this actually shows up and has values are on the positive x-axis. The only values of x that we can plug in to a square root are positive. So the only numbers that we can get out of this are positive, which means, is there any way for this radical to ever be negative 10? No. So really at this point, if we see that the radical is by itself, and not just a radical, any radical, but in radical with an even root, we're taking an even index, 2, 4, 6, 8, it cannot be equal to a negative number. It just does not work.
So, let's say, like, wait, even root?
So 2, 4.
Okay,
So if it's an even root, it doesn't work. Now, if it had been a cubed root, it would work just fine. Because if this had been cubed, negative 10 to the third power would have told us that 5n is equal to negative 1,000. It still works out just fine. Can we kind of see the difference there? Now, if we did miss that, and it didn't make, and we missed the fact that we had the square root equal to negative number, we can work through it. We can go all the way to the end and check it and see, as we did there, okay, it doesn't work, so it's a no solution. second square root 5x. We said this was graph. Yep. Let's say zoom. I'll zoom. Let's see here. 0. Well, the line at the very bottom is 3. The blue one is our other graph. Do they get anywhere near each other?
No, they're far apart.
That's also part of the reason we have no solution.
That's like me and Mariah's friendship.
Let's look at this one here. We have one radical. Need to get it by itself, so minus 10. Exactly. Because we have an even root that's completely by itself equals a negative number. So again, before you just jump to the fact that it is no solution, make sure that radical is completely by itself. Because if it had worked out to be negative square root of 3m, multiply both sides by negative 1, the 9 is now positive, it works. But if this radical is completely by itself, there's nothing being multiplied or added or subtracted from it, and it's equal to a negative, it's not going to work.
You said if it was negative 3m, then multiply it by 1, right?
So if it was negative in front,
Oh.
then we can divide both sides by negative 1, telling us the square root of 3m is, and that does work.
What if the negative was
Inside? So let's say this here, and we can say negative out front. So we would still subtract the 10. Negative square root of negative 3m equals negative 9. Divide both sides by negative 1 tells us the square root of negative 3m is equal to 9. Square both sides. Negative 3m is equal to 81. Divide by negative 3, telling us m is equal to negative 27.
And if that were a real question,
And let's check.
right, check.
So here, we can do just the radical first. So second square root negative 3 times negative 27 is positive 9. We have negative 9. Well, that'd be negative 9 plus 10. So it still works. It's just that whatever the value of m is has to offset that negative 3. So the negative and negative, negative 27, negative 3, made a positive 81, which did work. Does that make sense? And when we check it, the number that we end up in here has to be positive, because really we're saying negative square root of 81. The number became positive. Does that make sense? Let's look at this one here next. Now, on a whole, this is not any different. There's just one main step that's going to be a little bit different. We do have one radical. It is by itself. Yes? So we're going to put both sides to the second power. And on the right-hand side, the radical and square would cancel, because that's the only thing over there. When we square it, we're going to have 7p plus 15. Now the other side, p plus 1 squared. This is the first time we've had two terms on one side, yes? So really what this is saying is that I have p plus 1 times, which we have to, p times p is p times p 1 times p is plus p plus 1. We've got to use our distributive property again. It's very tempting to just say p plus 1 squared is p squared plus 1, but we have to multiply it out. Yeah. Now we can combine our like terms. P plus p is 2p.
Yeah, Wyatt. Give us a second to write it out.
Questions on how we got to this point here? Now, yes, at this point we need to get this equal to. So we can subtract 7p from both sides, which will tell us that p squared minus 5p plus 1 is equal to p squared minus 5p minus 14 is equal to. Now, again, we can factor like we've been doing up to this point. Is the number in front of p squared 1? Yes. So that means that the factors or our solutions are most likely not going to be fractional. So I could say that it's x squared minus 5x minus 14, yes? Graph. I'll zoom 6. So where it crosses the x-axis would be solutions. -2 and 7. So p is equal to -2, and p is equal to 7. These are our two solutions. I would still check them just to make sure. So with -2, we'd have -2 plus 1 is equal to the square root of 7 times -2 plus 15. Well, -2 plus 1 is -1. Second square root of 7 times -2 plus 15 is 1. That's not true. So p is not equal to -2. Yes. Well, 7 plus 1 is 8. The other side is also 8. So p is indeed equal to. So with having two terms on the other side, did it make it any challenging or more difficult? No. The only thing we had to pay attention to was especially doing the p plus 1 times p plus 1 and making sure we actually multiplied that out. Any questions on this here? Do we feel comfortable with these here? Let's look at this one here because it's not any more challenging. It's just, is the radical by itself? So we would need to subtract 4 from both sides, which will tell us we have the square root of -3m. N is equal to. Yes. So we minus the 4, we get this. Now we can square both sides because the radical is by itself. We put both sides to the nth power. Those will cancel. -3m plus 10 is equal to m minus 4 times m times m is m times -4 is negative. -4 times m is -4m. And -4 times -4 is plus. We combine them. If one was positive and one was negative, then they would indeed cancel. Now we need to get this equal to 0, yes? So what two things are we going to end up needing to do? So we'll need to add 3m. And I haven't done that at all day today, doing both at once. There's nothing wrong with it. And especially if you feel comfortable doing the two steps at once, that's perfectly fine. M squared. X squared minus 5x.
No, because it's a positive, so they're both negative.
So it's positive 5,
No,
negative 5 plus 6.
yeah.
That's it. Graph. So the answers are,
6.
yeah.
26.
So if we factored it, yeah, it would be m minus 2 and m minus 3. But to get m minus 2 to be 0, we need m to be positive 2, and the same with m minus 3. Now, we have these two here, m equals 2, m equals 3. Now we can check it, because up to this point, if the value of the variable is negative, it didn't work, right? So we have two positive numbers, so they should both work. By that. Now let's check them, make sure. So 2 plus 10 is equal to 2. So we don't have a negative on the other side, so that's kind of nice. Now at this point here, I can type that whole thing in. I don't have to do it part by part. So we can say 4 plus second square root, already lost, negative 3 times 2 plus 10. And this should give us 2, yes? So now we just need to check 3. 4 plus negative 3, or square root of negative 3 times 3 plus 10 is equal to 3. So in the calculator, we can do 4 plus second square root, negative 3 times 3 plus 10, and this should give us 3. So even though both values of the variable that we found are both positive, didn't necessarily guarantee that they were going to work. So we still need to check them, especially if the variable is outside the radical. On the test, I will tell you specifically to check it if you need to check it. But I think we feel comfortable with these here, yes? We will cover one like this when we go over 5.2 or 2, where are we at? 5.4.3. We'll look at these here, where we have more than one radical. This is where step 3 is going to come into play. That's fine. I think the first hours are going to miss it. Yep. So, however, the homework for this here is on page 269, 45, 46, and 49 through 57. One thing I will point out about 45 and 46 is it says state if either or if each one is an extraneous solution. It gives you an equation, a radical equation, and gives you two solutions, and it wants you to pick which one is the extraneous solution, the extraneous value. And as a reminder, extraneous is the ones that don't work.